This slide shows how digital signature algorithms work in general. Let's assume that the sender and the receiver have agreed on a public-private key pair. In the next slide, we will show how this agreement takes place, and we'll see that certificates are used for that. The private key is only known to the sender. The public key is, as the name implies, public information. Anyone, including the receiver, of course, may know the public key. The sender computes a checksum over the sent message and then encrypts this checksum using the private key. This results in a signature, which is also known as a hash-based message authentication code, or HMAC. The sender sends the signature along with the message itself to the receiver on the right. The receiver computes the same hash over the received message, and the receiver also decrypts the received signature using the public key. And then the receiver compares these two things. If the decrypted hash matches the locally computed hash, then the receiver knows two things. First of all, the receiver knows that the message must have been sent by a party who is in possession of the private key, and this is part of the authentication procedure. And also the receiver knows that the message was not modified in transit, and this is part of integrity verification. The purpose of this slide is to explain how certificates are used in the context of IPsec. Now, this slide is extremely busy on purpose because I wanted to make clear how complex the process is, and I'll just highlight some of the key points. Here, Alice, in blue on the left, uses a digital signature to sign all the messages that she sends to Bob, which is in green on the right. Alice uses her private key to create these digital signatures. Also, Alice sends her certificate to Bob in the IPsec exchange, which serves two purposes. First, that certificate that Alice sends to Bob contains Alice's public key, which allows Bob to verify the signature on the messages that he receives from Alice. And second, that certificate that Alice sends to Bob binds Alice's identity to her public key. And this allows Bob to authenticate Alice. Alice's certificate is signed by some certificate authority. Now, in the case of IPsec, the certificate authority is very often the operator, which is shown in red at the top, acting as a private certificate authority. The operator's certificate is installed on Bob as the root of trust, and this is what allows Bob to verify the validity of the certificate which he received from Alice.